At this point, we've learned a lot about forces. Forces are pushes or pulls on an object. Forces can cause change in motion. Forces can speed up an object or slow it down. Forces can be contact forces, such as applied forces or friction forces, but forces can also be non-contact, such as gravity or magnetic forces. Forces are most commonly measured in newtons. In this tutorial, we're going to learn about net force. That is, the addition of more than one force. So consider that you could push on an object with a force of 100 newtons. And if your friend can push with a force of 60 newtons, then how much force can you both apply to the box if you both push? Well, first, let's draw a little picture of the object with both forces being represented by arrows in the direction of the force. The 100 Newton arrow, that's your push, is shown to the right here. Then we have your friend's 60 Newton arrow, and we'll draw it a little bit shorter to show that it is a smaller force. And so here we are with the object and the forces on it. And we call this little sketch a free body diagram, which we often just write as FBD. The free body diagram is used to make a situation look really simple. So now let's consider what's happening here by referring to our free body diagram. Now, since you're both pushing in the same direction, that is, the force arrows on the free body diagram are both in the same direction, we could just add the forces together and determine that the box receives a total applied force of 160 newtons to the right. So, we'd say that the net force on the object is 160 newtons to the right. The change in motion of the box would be as if there was just a single force of 160 newtons to the right. Another example, what if your friend was pushing, this time in the opposite direction of you? So they're pushing on the other side of the box. So you're pushing with 100 newtons to the right, and they're pushing the other way with 60 newtons to the left. Then what happens? Well, let's first draw our free body diagram. And this time, the arrows would be going in opposite directions. Your force is going to the right again, but in this case, your friend's force is to the left, a little bit smaller again. So your forces are opposing each other. So they wouldn't add the same anymore, would they? Your friend's force would be canceling out part of your force. So you're pushing harder, so the net applied force experienced by the box is your force, 100 newtons, minus your friend's force, 60 newtons, which equals 40 newtons to the right. So we would say that the net force on the object is 40 newtons to the right.